Hello and welcome. So we're going to cover chapter 9.3. I'm going to give you guys the tools to check your answers. And if anyone has questions and they want to see the answer specifically, reach out. I'm happy to provide those to you. So let's start off with our unit circle, a perfectly drawn circle as always. Use your imaginations if you don't mind. Okay. This is for 9.3 in Big Ideas Math for Algebra 2. This is Exploration 1. Question A. So we're given this point here, and this point is negative 1/2 root 3 over 2. And we're told that this is the unit circle. So let me bring you guys in a little closer. So we have this point right here where our x value is negative 1/2 and our y value is root 3 over 2. You guys can see our right triangle here. Some of you guys might recognize it as a special right triangle. There's our 1, because this length is 1, just like this length is 1, just like that length is 1, just like that length is 1. So you guys might recognize this special right triangle as a 30, 60, 90. Bravo and bingo. But you don't need to actually know that. All you need to see for this exploration to be able to do the sine of this theta, the sine of this angle, the cosine of this angle, and the tangent of this angle is this triangle. So let's start off with our sine of this angle. In this case, opposite over hypotenuse. The sine is tied to y here. So we have our root 3 over 2 divided by 1, which is really root 3 over 2. We have our cosine theta. In this case, it's going to be our x value, our adjacent value, over 1, over the hypotenuse, adjacent over hypotenuse. But our hypotenuse is just 1, and you can divide something by 1, and it won't change it. So for this one, once again, we have negative 1/2. Let's look at tangent now. We have root 3 divided by 2. It's going to be opposite over adjacent, right? So root 3 divided by 2 over, or divided by, over negative 1/2. Now you'll notice I didn't actually write this. With in this form, negative or root 3 over 2 divided by negative 1/2. Now I chose to do it in the fractional division form. Some of y'all might recognize it from elementary school or middle school. But why do I do it this way? Because it's easier for me to work it. I got root 3 over 2 divided by negative 1/2. Well, that's going to be times 2 over negative 1. 2 divided by 2 is going to be 1. So we're left with root 3 divided by negative 1, which is the same thing as negative root 3. And that's our value for tangent. Here's our value for cosine and our value for sine. So that was the exploration 1, part A. Let me now jump into the homework problems. I gave you guys 3, 5, and 7. Really shouldn't be that too much different. The main difference is that we're no longer working with a unit circle. So let's do 5, actually. 3, 5, 7. Let's do 5. I think I might have done 3 with a lot of you guys already. So let's do 5. This is going to be on page, let's see. Page 482. Once again, this is 9.3. Okay. Number 5, we have our Cartesian plane, our XY plane, our two-dimensional plane, and we have our theta here, negative 6, negative 8. Let's see, yeah, that's our theta. And our angle is going to be right there. Okay, now that angle is, oh, we don't know the angle, but we do know that point right there. That point right there is -6, -8. -6, -8. Okay. So we're looking for this theta. Let me erase this so that I can start drawing our triangle again. It's the same concept, except we're not working with a unit circle. So in this case, my x value is going to be from here all the way out to here. And this x value is going to be -6. And then our y value is going to be all the way down to here. And our y value is going to be -8. Now let me redraw this triangle right here for you guys to see. 6, 8. Now, to figure out this hypotenuse, this third side, when it's not the unit circle, we actually have to use something that some of us might be familiar with, Pythagorean theorem. So we take our legs, square them and add them together. A squared plus b squared equals c squared. So 6 squared plus 8 squared equals c squared. So we're going to have 36 plus 64 equals c squared. So c squared equals 100. That's 100. So you take the square root of 100. Yeah, you guys already know. C is equal to 10. So this value right here is 10. This length right here of this triangle is 10. And here we see our triangle. This is the triangle that we're working with. Looking at our angle, we can now see that figuring out sine, cosine, and tangent of theta is another pretty straightforward problem. So theta here is going to be, for sine, is going to be opposite over hypotenuse, -8 over 10. -8 over 10. And for those of you guys who already know, this can be reduced to, let's see, -4 over 5. Yeah. Cosine is going to be adjacent over the hypotenuse, so that's going to be -6 over 10, which can reduce down to -3 over 5. And last but not least, we have tangent, which is sine over cosine, opposite over adjacent. So -4/5 divided by, you see, I do the fractional division form, old school, but it's so much easier. -4/5 divided by -3/5, which is the same thing as saying, rewrite this. It's the same thing as saying -4/5 times 5 over -3. The 5's here divide out, they cancel, and we're left with -4 over -3. The negatives cancel, so we're left with 4/3 for our tangent. And that right there is the question for, or that right there was question 5 for section 9.3. Thank you, and let me know if that does not help enough, if you need more methods for 7 or 3, or you need more videos for 7 or 3, or if you just want to check your answers. Thank you. Cheers. Go Hawks.